So let me introduce one more new topic, which is phasor, phasor representation of representation of phasor representation of sinusoidal functions. Sinusoidal waveforms, otherwise waveforms. Okay. So what are the sinusoidal functions? Generally, any function which have the pattern of either sine or cosine, as like this Vm sine omega t, or let me go in general way, plus theta, or Vm cos omega t plus theta. Either of these functions can be called as the sinusoidal functions. Okay, and in which, so the generalized most of the times what we do is that we will take up Vm cos omega t plus theta form, which is a general form. And for this waveform, so we would like to represent in terms of a new form, which is the phasor representation. First, let me introduce what is the phasor. Right. So here try to observe, in the sinusoidal waveforms we have majorly magnitude, which we call as amplitude, and phase shift, phase shift, which is theta, phase shift. Here amplitude is Vm, phase shift is theta. And in the last session we had seen, like when we introduced the lagging and leading concept, this theta significance, like if we introduce the plus theta, what happened? If we introduce minus theta, what happened? If it is plus theta, we seen some leading nature. If it is minus theta, we seen some lagging nature. So in generally, let me say that, so any sinusoidal waveforms can solely represented and fully characterized its nature by using only amplitude and phase shift. We no need any information about the angular frequency to describe the sinusoidal waveforms. This is the total story behind the representation of any sinusoidal waveform by phasor representation. And how we come to that conclusion that this amplitude and phase shift is only sufficient for representation of sinusoidal. For which, just let me take up this small experimentation, that so if I have some vector as like this, some vector or phasor, whatever it may be, and whose length is Vm, and assume that this side position is fixed and it is rotating, this arrow is rotating in clockwise direction, somehow like this, just let me say in this way. So right, so I think everything is moving, so instead of that, yeah, so just if I'll take this, better to take the dotted line, so just wait. So let us take some dotted line, and let me take circle. Sorry, bear with me. Just what I want to show here is that, assume that this arrow is rotating in some direction. I'll show that along this path, along this dotted line path. Now assume that this arrow is rotating at an angular velocity in anti-clockwise direction. Angular velocity is constant. At a constant angular velocity, it is rotating in anti-clockwise direction. As a result of this, some interesting phenomena going to take place. So what is that just try to see every time what are we interested is that if I'll take the projections of these rotating vector onto the vertical plane. This is what the vertical plane. This y-axis we call it a vertical plane. And this x-axis I'll take its corresponding instants of times. So the first instant is t0. This is what the t0. Here is the t0. When this red arrow moves over here, let us call this is t1 position. When that same red arrow moves over here, let us call this is t2 position, and so on like this. T3 position, T4 position, T5 position, and T6 and T7, and coming back to T0. So with this way, try to observe this vector arrow line has rotated one complete rotation. So let me indicate those things first. So that is T0 is already represented. So T1, T2 and T3 and so on up to T7. So what I'll get is that out of this I'll get a sinusoidal function something like this. First let me draw this sinusoidal function. Then I'll show what is the relevance of that with this as like this and as like this, right? So now let me represent its corresponding segments. Now see that if you consider this as the vertical, this as the vertical plane equivalent to y-axis. If I'll take the projection from here onto the vertical plane, it look like the midday of your shadow. How much is your shadow? It look like locating at the origin, means zero value. That is what T naught position. If you are at the position of T1 and if you project this corresponding tip of the vector onto the y-axis, how much length you will get? That is corresponding amplitude at that instant of time. So let me say the corresponding value is equivalent to this much, and whose corresponding instant of time is t1. Then as it moves to the position of t2, what will be the projection of that onto this vertical axis is its full length. So at t2 its length is equal to maximum value, which is equal to Vm. This is what the Vm. So like that, if you will keep on projecting this rotating vector projections onto the vertical plane will gives the instantaneous values of the voltage of a sinusoidal function. Now as it go beyond T2 position like T3, then amplitude is decreasing. Now I want to project this onto the vertical plane. Now it is decreasing. So this decreased value. If it is at T4, then I will get again 0. This is what the T4 position. Like that T5, then it is negative projections. This is at T5. Then at T6 maximum value but negative. Then T7 sudden decreased value, and at T0 again or T8. So this is what the projection of, let me write these words, these are very important. So what we say is that basically the phasor we define in this way. So it is a rotating vector. It is a rotating vector. Let me write Vm in counterclockwise direction in a in counterclockwise direction. Counterclockwise direction. At a constant at a constant angular velocity. Angular velocity. So this is the basic definition of the phasor. Phasor definition is that it is a rotating vector in counterclockwise direction at an angular velocity omega. And next statement, continuation to this is that then the projections of the, or let me write directly, the vertical projections, the vertical projections of rotating vector of rotating vector will produce the instantaneous values of sinusoidal functions. You should understand what is meant by instantaneous values. Instantaneous means at every corresponding instant of time. Like if I see, like by my observation, let us say the rotating vector is at this location. Then what I will do is that I will project this corresponding point onto the vertical plane. This is the corresponding height. How much is the height? This much is the height. Once I will project it. Now you see that at this instant, at t5 instant, you will get a sinusoidal amplitude of this much height. That is what this value. This is the amplitude. Means this sinusoidal pattern can be tracked by using this rotating vector. In which try to observe, one of the thing is constant. What is that? Is angular velocity. So as because it is constant, it doesn't matter in which domain are we choosing. So whether we are choosing with only magnitude and phase, or magnitude, phase and angular velocity. As because the angular velocity is almost constant, even if we neglect that representation, even if we neglect that angular velocity in our representation, there is no much effect on the characteristics of the sinusoidal. That is what the phasor representation will come over like this. So let me take some generalized function. So in either way as like this. So if I'll consider either current or voltage, it's your wish. So let me take the voltage. V of t is equal to Vm cos omega t plus theta. This is generalized function. Now from this function, which is function of time, see that if I will substitute t is equal to 1 second, I will get the voltage at 1 second, like that. At every instant of time, I will get that corresponding voltage. Now what I will do is that from this step, just I will try to write voltage as in this way. We know Euler's identity that e power j theta. How can we write e power j theta? Cos theta plus j sin theta. All of you know this. You might be seeing this as r e power j theta. So if it is r is there, then r into this we will get. This is what Euler's identity. Now can I write this cos corresponding thing as Vm e power j omega t plus theta, e power j omega t plus theta. So what I'll get if I'll split this? Vm cos omega t plus theta plus j Vm sin omega t plus theta, as like this. Or if you split only e power j theta, j corresponding thing, then what I'll get is that, or if you will get confused with this theta, you consider in this way, e power j phi with this format is equal to cos phi plus j sin phi, so that no question of that theta over here. So now I can split this into e power j cos omega t plus theta plus j sin omega t plus theta. But sin omega t plus theta was not there here. So what shall I do is that, just I will say real part of this entire representation. Real part means only this portion. Only this portion. I don't want this portion, imaginary part. So that's why I said RE means real part. RE means real part. So then I can say both are equivalently same. Okay, just if somebody expand this waveform, what I'll get is that Vm cos omega t plus theta plus j Vm sin omega t plus theta. Out of this entire equivalent thing, what I am considering? I am considering only real part, this part. This part I want. I don't want this imaginary part. That's why I said RE means real part of this entire big representation. Now in this representation, in the one more next step, what I will do is that V of t as like this. So can you observe that this is e power 2 terms we can split as e power j omega t into e power j theta. Okay. So out of that, just simply I'll consider, or let me take one more step. So Re of Vm e power j, or let me write, yeah, so j theta first term means this j into theta term into e power j omega t. And here, so what I'll do is that directly, this is the direct step actually. So this is the simplified version so far. Now in the next step, what we do is that we don't want all these kind of things, that e power j omega t we don't want. Why? Because omega does not affect our representation. We had seen that, as because it is a constant angular velocity. So as because this parameter is constant, we can make this to be as some new representation, which is V bar, which is equal to simply Vm e power j theta. We can reach to this equivalent from here. Means what I am doing is that I have many things available. Out of that I am taking whatever I want for simplification of the entire sinusoidal calculations. And but that should be considered carefully, that based on certain factors. What is the factor is that, as because omega is constant, I am neglecting this portion. This portion of the term is neglected. Then if we neglect that portion of the term, then what we get, the final representation is that this is what the important new representation which we need actually. So now out of this given representation, that is Vm cos omega t plus theta, every time we can go with this kind of thing as, let me once again simplify this as Vm e power j theta can be written as Vm at an
సార్
angle
మళ్ళీ
theta.
ఇది ఒకసారి చెప్పండి సార్.
Okay, I'll tell you, I'll repeat that part. Okay, so first,
ఓకే.
no need to worry about the mathematical phenomena happened inside this. Just try to concentrate on the first step and this last step, that is 2, 3, 4. 1 and 4 you observe, that's all. So from 1, what I am doing is that directly Vm I am taking, and e power j corresponding to this theta directly. What I am interested ultimately is that Vm and theta. That's why I just took only Vm and theta in this format. The format or equivalently, this is Euler's identity or exponential representation. We can also represent this in Vm at an angle theta format, or we can also represent this in rectangular form as Vm cos theta plus j Vm sin theta. These three representations are very important. So all are equivalently same. Sometimes I may say in polar form, which is Vm at an angle theta. All of you know polar form? Polar form means R at an angle theta form. Rectangular form means x plus j y form. This is in rectangular form. See this last one. And this is in polar form. What about this first one? Exponential form. So r e power j theta is what the exponential form. Let me write exponential form. Exponential form, polar form and rectangular form. Rectangular form. So in either of the form we can represent these things. All are equivalently same. All are equivalently same. So what I am trying to say is that we are neglecting this corresponding portion of the signal. We have voltage signal. We are neglecting e power j omega t. There is a certain reason in neglecting that. If we neglect that, we will get much simplified version. So out of this expression, what I am trying to consider in representation of my sinusoidal is only this portion. Vm e power j theta portion. I am not considering rest of the portion. There is a reason. So we will understand as we move forward. So why we are using only Vm e power j theta. Why not e power j omega t also? Okay. So that we will see and we will understand slowly. Right. So but ultimately what you need is that these three forms which are very important. Vm e power j theta is equivalent to Vm at an angle theta or Vm cos theta plus j Vm sin theta. Okay. So this what we call as a phasor representation or vector representation. Let me write more specifically. This we call more specifically as vector representation. Vector representation. I'll tell you what is the difference between vector and phasor representation. Next is phasor representation look like this. Sorry. Phasor representation. So see this V e power j theta or V at an angle of theta or simply V cos theta plus j V sin theta. If you want, I'll add it. What is V means? V means RMS value of the voltage. VRMS, VRMS, VRMS. How much is the VRMS? For a sinusoidal, Vm by root 2. Vm by root 2. For a sinusoidal, VRMS is equal to Vm by root 2. That means if we express in peak values, it becomes vector representation. If we express the amplitudes in RMS value, that becomes the phasor representation. That is only the difference. Sometimes we may use either of the things also, but preferably go with this RMS values all the time. Okay. Now, so just to make you realize this, so let me choose some problems for this. So just let me take some examples as like this. Let us say 100 cos omega t plus or minus 20 degrees. So this is voltage V of t. Can you put this into phasor form quickly? V bar is equal to, tell me, how much is the amplitude? 100.
100.
But 100 is peak value. If I'll keep that in 100 only, it become the vector representation. But we know sinusoidal, how much is the RMS value?
Pm by root
Root
2,
2.
sir.
So this is what the 100 by root 2 amplitude. How much is the angle? So we should always
20.
focus only these two, quotient of cosine or sine function and omega t plus turn. Only these two are very important for us. Just put those things directly in this format. At an angle, this is angle symbol, angle of 20 degrees. That's all. This is what the phasor representation. Okay. So next is, let us say V of t is equal to something like this. Minus 5 sine something like 580 t minus 110 degrees. Minus 110 degrees. Now see that here the function is sine function, one thing. So preferably all the phasors must be expressed in terms of the cosine function. Okay. So that is first thing. So let me give some standard rules. There are three rules. One is express everything into cosine. Express every term into cosine form. Cosine form. This is the first rule. Then next is see that all amplitudes must be positive. We should not have any negative amplitudes. Next is all must be all must be either in sine or cosine to add those functions to add those functions. So I'll show for these three some examples also, so do not worry. So but these are the three conditions every time you should remember. One thing is that every time we will express everything into cosine form, and we see that all amplitudes must be positive, and we see that if we have more than two terms, like some plus something is there, then if one is the sine, other is in cos, so we should convert everything into either sine or cosine. But ultimately again I need cosine form only. Okay. So that is what the thing. So let us see this. For this, what shall I do? For this example, see that amplitude is negative, first thing, and angle, whether it is negative positive, it doesn't matter. And what else is there? Important observation, this is cosine. So what, sine. What shall I do is that I shall convert this sine into cosine form. So let us do that part first. So for which, so usually, so you can follow some trigonometric functions table in this way. So just see that I will follow in this way. I will take this corresponding axis as a sine axis. Sine, let us say some omega t. This I will take as cos omega t. This I will take as minus sine omega t. This I will take as minus cos omega t. Now listen carefully. If we move from this position in anti-clockwise directions, all anti-clockwise directions are referred as positive angles. Positive angles. So if this is the 0 degree position, if I'll move up to this, then I will gain plus 90. If I'll move further, by this time I'll gain 180 degrees. If I'll move further, I'll gain 270 degrees in my account. So further 360 degrees. In other words, if I'll travel in clockwise direction, this is anti-clockwise direction, right? So this clockwise direction angles are referred as negative angles. If I'll move up to this, so I'll gain 90 degrees but negative, minus 90 degrees and minus 180 degrees, minus 270 degrees, like that. Okay. Now see that what I need, this sine I need to be converted into cos, that is first thing. Where are the cos? Cos are existing only here. But ultimately which cos you need? All amplitudes must be positive, so I need this cos. From which I need this cos? Do I need from the plus sign or minus sign? From which, let me write that expression over here instead of referring every time up and down. So see that just it may be a simple mathematical thing, but try to understand carefully. What I will see is that here minus sign is there. I want to convert this minus sign into just cos. That's all. For which what shall I do is that for this if I'll move in some direction. So see in this table, if I'll move in backward direction, that means clockwise direction. By how much angle? From here, 90 degrees. But this clockwise angles are negative angles, so minus 90 degrees. So from here, if I'll add minus 90 degrees to my signal, I'll get cos. That is one thing. Okay. So in other way, I can also equivalently say in this way, for cos, if I will add plus 90, I'll get minus sign as like this. So if somebody feel this as a difficulty, but this is the best thing. So to write sine to cos, cos to sine, anything. So you can refer any your own methods also, no issue. What I'll do is that I'll do in this way. Cos of omega t plus 90. How much I will get? Minus sine omega t. Okay. So now see with this formulation, can I make in the above expression that so this minus I will take out, then I will write 5 cos of 580 t plus 90 means which is already available, let me write minus 110, this is already available, this entire thing is already available. Next is, so this plus 90 is additional thing. So can I say this entire thing is equivalent to minus sine omega t? What does it mean? So it is equivalent to minus 5 sine entire this value. So what I did is that this sine and negative value I converted into cos form. How? By adding 90 degrees to the cos. Cos omega t plus 90. Okay. So now, so with this, so just simply see that now I got positive value, but here two things are there. So let me write 580t. So minus 110 plus 90. How much is this? Minus 20 degrees. Now see that how can we represent this in phasor form? Tell me. So once we go with the phasor, we say capital letter on top of it bar, and we look for the magnitude and magnitude should be RMS value preferably. So 5 by root 2, and angle is minus 20.
minus 20 degrees.
So this is what the phasor form of the given signal V of t. Okay. So in this way you can try on your own. So how you do it, it's your wish. So just let me take one more problem quickly and wind up. So one more example. So now let me take two terms as 3 cos 600t minus 5 sin 600t plus 110. So quickly do this in phasor form.
సార్ మైనస్ పైసా ఎన్ని కాస్ట్ లాగా మార్చాలి
Exactly,
సార్.
exactly. So this part we already did. See, minus sign something. Minus sign I need into cos. Okay. So what shall I do for that? Let me write first term as it is 3 cos 600t. This minus sign I will try to write in this way, cos of this entire value whatever we have already, this entire value whatever we have already, that is 600t plus 110 plus 90.
90 సార్ 5 పెట్టలేదు కదా సార్ ముందర 5 కాస్ట్ కదా సార్.
Yeah, 5 also there. Okay. So 5 will be there. So what I did is that just I will refer this very quickly in this way. Every time usually just from when I was studying these things, just I'll write in this way, sine, and this is cos, this is minus sine, this is minus cos. Now what I need is I will check. See that I have minus sine. I need to be, this need to be represented in cos format. So what I have to do? For cos, if I'll add plus 90 degrees, I'll reach to the minus 90, minus sine. So directly I will add for this cos, I'll take this whatever sine has, that is 600t plus 110. For that I am adding 90 degrees. That's all. Okay. So in this way you can convert. Now see that. So this is, you can make in this way. So putting together this, I can first term can be written as 3 by root 2 at an angle of 0, and second term I can write 5 by root 2 at an angle of 200. 90 plus 110. Now you can convert this into again rectangular form and you can add it and you can get the resultant. So this is 0 degrees, so no issue. So this becomes only 3 by root 2, and whereas this becomes some value, so you cross verify how much is this, like 5 by root 2 cos 200 plus j sine 200 degree. See that your calc is in degree mode. Now you add up real parts and imaginary parts, then again simplify. Let us see how much you will get. So I will be getting this value as, so 1 second, this as, I am getting this entire thing as 2.41441 divided by root 2 at an angle of minus 134.8 degrees.
సార్ అది ఒకసారి క్యాల్సియం ఎలా చేస్తారో చూపిస్తారా సార్?
Yeah, so I will take
డిగ్రీ
special,
మోడ్స్.
I will take one special session for that. Why? Because handling the complex number is very important for the AC system. Okay. In the next class,
ఓకే సార్.
so I will completely deal with the calculator. So after having understood these phasor representations, so I will completely concentrate on that, how to do by using calculator. As of now, you can proceed in this way, like converting the polar form into rectangle form and adding all the real parts. This is one real part, this is also one real part. You add these two terms first, then again convert back to polar form. Okay. So like that, if you will do, you will get this much value, right? So next, just let me give one more simple question and let us see how many of you will do this problem. Uh, this is just like homework. So 8 cos 4t minus 30 degrees plus 4 sin 4t minus 100 degrees.
8
So
by square root of 2
yes,
angle minus 30 degrees plus 4 by square root of 2 angle minus 100 degrees, sir.
see,
No,
but
sir.
yeah, so this is a cos, but this is a sine. So you need to
Fine, yes, sir. Change
change
చేయాలి.
this, yeah. So this first
Yes, sir.
term will be as it is. So 8 cos 4t minus 30 degrees. Now this is the second term we need to make. That how we do that? Check it. So what I need? Cos I need. Okay. So what function is available? Sine function is available. So again let me take this table quickly. So this is the sine available. Cos I need. Okay. So this is minus sign, however not required. This is minus cos. What I need? This I need. What we have? Sine we have. So how can I get? That you have to look for it. Okay. So this cos is equivalent to say that if I'll move from that cos from the desired to available. Desired to available. Previously also see how I proceeded. This is what my desired. To available. What is available? Minus sign is available. Here also see. What is the desired? Cos I need. But what is available? Minus sign is available. From desired to available you move. In which direction I am moving? If it is so, see this is what my desired thing and what is available is
Minus
sine.
90, sir.
So this is in clockwise, so this is minus 90 degrees. So simply I will say 4 cos this entire thing 40 minus 100, so minus 90 degrees. That's okay. So now everything is in cos and all amplitudes are in cos. So complete this and tell me in final phasor form, single form, that in this way magnitude and phase. Okay. Thank you.